Alright, I'm back with an early morning video, one of the best videos. Now, my last video, I was having really bad audio. I think it was like maxing out, the gain was too high. And I did that because my prior videos had audio that was too quiet. So I guess I'm just going to go with the quiet audio because the audio in my last video was just completely unacceptable. So I'm going to stick to this, and if it's too low, there's an extension called Volume Master you can get, and you can spike it up really high, and it just spikes up that one tab. So if it's too low, I recommend installing Volume Master. It's a really good extension. All right, so let's move on to look at my channel. So I got to switch over to it. Oh, thank you to all the subscribers. It really does help. I kind of went at this without the intention to be like a YouTuber. I don't ask people to like and subscribe really, but it really does motivate me to keep this channel going, and feel like I'm doing something kind of worth my while and worth everyone's, the people who subscribes while too. So that really does help. Thank you. I'm grateful for this number being significantly higher than this number, but I'm catching up. I'm catching up to you guys. It's a competition. So we're gonna do part 4 of chapter 14, which is all about machine learning and machine ops. So this is the machine learning ecosystem. Let's take a look at the Python machine learning ecosystem. There are really 4 main ideas: deep learning, sklearn, AutoML, and Spark. In the area of deep learning, the most popular frameworks in order are TensorFlow-Keras, PyTorch, and MXNet. Google is sponsoring TensorFlow, Facebook is sponsoring PyTorch, and MXNet comes from Amazon. You will see MXNet mentioned quite a bit by Amazon SageMaker. It is important to note that these deep learning frameworks target GPUs, giving them performance boosts over CPU targets of up to 50%. All right, so we've got the 4 most popular machine learning frameworks and ecosystems. On the left here, we've got the deep learning frameworks that targets the. Oh, this is interesting. So it looks like we've got them separated out by the targets. So in these 3 here, they target the GPU and the CPU. But it looks like we've got one here that only targets the CPU. So if anyone's watching this and you want to try some machine learning and you can't get your hands on a nice GPU, maybe try this one here. Let's take a look at this further. So this is sklearn. It targets the CPU. So if you don't have a expensive GPU, maybe this is the one for you. It uses NumPy and it uses pandas, kind of in a circle here it looks like. And then it can use NumDa targets, and then that uses a GPU. Now I have done I did a full machine learning course on here before. It was an introductory course, and I did learn about renting out GPU power, just like you can, like cloud networking, like how that works, but for machine learning hardware. So don't let your hardware slow you down. If you want to learn this, maybe check out this scikit-learn and just kind of use your CPU if you don't have a nice GPU. And then when you really get something where it's like, I believe in this, maybe save up and then and then run it against a kind of a cloud service, and really just having a really solid understanding of this will go a long way. I'm going to take a look at the Numba targets. So here it is. Yeah, I'm really not sure what these are, and I'm not going to make assumptions. That typically, if you do that, you have to unlearn your assumptions and you add a whole extra step. So kind of forget about what I said for now, and if it rings true later on, then that's why it's on video. You can go back and watch it. So then we've got the deep learning frameworks that. So we've got deep learning. So it's four different things, and they say that here. There are four main areas: deep learning, sklearn, AutoML, and Spark. So deep learning is here. We've got three different open source tools we can use for it: PyTorch by Facebook, TensorFlow/Keras. I don't know why there's two names there, by Google, and then MXNet by Amazon. We've also got scikit-learn, which is Panda and NumPy. And then we've got this here. I'm not sure how that integrates. It's just a bidirectional line between NumPy and Numba outside of the loop that includes pandas. And then we've got Spark. We've got Amazon EMR. We've got Databricks. And we've got GCP Dataproc. And then AutoML. So Uber open source uses that. And then H2O open source. So let's move on. The sklearn ecosystem often has pandas and NumPy in the same projects. sklearn also intentionally does not target GPUs. However, there's a project called Numba that does specifically target the GPU, both NVIDIA and AMD. Okay, so if you want that extra boost, you can bring in this this extra thing here and apply this to a GPU. So that's kind of cool. But I think what I said probably still holds. If you don't have expensive hardware and you want to learn this stuff, focus on scikit, and then if you want to take your project to the next level, you can get your hands on a CPU. You haven't shot yourself in the foot because you can use this Numba and use that to run it on a GPU. In AutoML, two of the leaders are Uber with Ludwig and H2O with H2O AutoML. Both can save significant time by developing machine learning models and can also potentially optimize existing machine learning models. Finally, there is the Spark ecosystem, which builds on the legacy of Hadoop. Spark can target GPUs and CPUs and does so via many different platforms: Amazon EMR, Databricks, GCP Dataproc, and more. All right, I'll pause it quick. All right, I'm back. Deep learning with PyTorch. Now that the ecosystem for machine learning with Python has been defined, let's take a look at porting the simple linear regression example to PyTorch and run it on a CUDA GPU. And I'm curious what a CUDA GPU is. We live in the age of AI, so I will do things that I can do in this age instead of using bronze tools and driving a horse-drawn carriage. What is a CUDA GPU? Is it not going to read it? Oh, you know what? I think I don't have my... No, it's not connected. Oh, and I gotta change... Oh,
Capable of executing programs written
okay, it's
using the CUDA
connected
platform.
now.
CUDA GPUs have a scalable array of multi-threaded streaming multiprocessors (SMS). Applications. CUDA GPUs are used in a wide range of applications, from image and video processing to computational biology and fluid dynamics. They are particularly effective for tasks that can be parallelized, meaning that the task can be divided.
Alright, I'll redo this, and I'm gonna listen to this whole thing.
A CUDA GPU refers to a graphic processing unit (GPU) that supports CUDA Compute Unified Device Architecture, which is a parallel computing platform and programming model developed by NVIDIA. CUDA enables dramatic increases in computing performance by harnessing the power of the GPU. Here's a breakdown of the key elements. CUDA platform. It's a software layer that gives direct access to the GPU's virtual instruction set and parallel computational elements for the execution of compute kernels. Programming model. CUDA comes with a software environment that allows developers to use C, C++, and other programming languages to develop software that can run on CUDA-enabled GPUs. CUDA GPS hardware. These are NVIDIA GPUs that are capable of executing programs written using the CUDA platform. CUDA GPUs have a scalable array of multi-threaded streaming multiprocessors (SMS). Applications. CUDA GPUs are used in a wide range of applications, from image and video processing to computational biology and fluid dynamics. They are particularly effective for tasks that can be parallelized, meaning that the task can be divided into a number of simultaneous subtasks. Key features: parallel processing. By allowing many threads to execute in parallel on the GPU, CUDA can greatly accelerate processing for tasks that can be divided into smaller, independent tasks. Memory management. CUDA provides various forms of memory accessible to the kernel during execution, including global, shared, and constant memory, each serving different needs for speed and scope of accessibility. Development ecosystem. CUDA Toolkit. NVIDIA provides a toolkit that includes a compiler, libraries, and debugging and optimization tools to develop applications with CUDA. Libraries and frameworks. There are many CUDA accelerated libraries and frameworks for deep learning, scientific computing, and more, making it easier for developers to integrate GPU acceleration into their applications. In summary, a CUDA GPU is not just any GPU, but specifically an NVIDIA GPU capable of running applications developed with the CUDA platform, allowing for high-performance parallel computing. This capability has been a driving force behind the adoption of GPUs not just for graphics rendering, but for a broad array of computational tasks.
Alright, so are any CUDA GPUs not NVIDIA?
No, CUDA GPUs are exclusively manufactured by NVIDIA. CUDA.
Well, that seems bad. What if NVIDIA goes out of business? I'll ask it that. Oh.
If NVIDIA were to go out of business, it would indeed have significant implications, especially for sectors that heavily rely on CUDA and NVIDIA's GPU technologies.
Also, what of innovation? What of like the free market? How much is it holding back? That one company, that only one company can create AI suitable hardware. And just as an aside here, one of the things I really talk about a lot on this channel is curate your information stream. Make sure that you're only getting information on your feeds or whatever from things that you expect to see and things that you're happy to see. So I'm an amateur juggler, so I have some juggling stuff in there. But this is my technology channel, so it's pretty much all technology things that I specifically decided, okay, this is okay to have in my brain, so it's okay to have in my feed. And one of the people I've given that privilege to is should be popping up here hopefully. Oh, did I not? Oh yeah, George Holtz. So he's a tech god. So one of the things he's been doing in his recent streams is doing a deep dive into NVIDIA products. So these are just fascinating to watch. I definitely recommend looking. I've learned so much from him. I just watched him use Python for like 30 seconds, and I learned so much about like what an iterable object is. It's like you can for loop through anything that's an iterable, and like he uses Python in like such creative ways. Python is like a language he's all about, and like he's really talented in Python, but he's talented in everything. He's definitely worth a follow, especially if you're interested in AI, because yeah, he's really looking at what NVIDIA is doing, and this flag in the background is not there by accident. So if you're interested in learning more about NVIDIA GPUs, I would definitely take a look at George Hotz. All right, so also, what of invention? What of free market? How much is it holding back advancement of technology that only one company can create AI suitable hardware?
The scenario where one company, such as NVIDIA, holds a dominant position in providing AI-suitable hardware, such as CUDA GPUs, raises valid concerns about innovation, competition, and the advancement of technology.
I want an AI
Here's
company.
an analysis of the potential implications. Innovation pace of innovation. A dominant player with substantial resources can invest heavily in research and development, potentially accelerating innovation in certain areas. However, if the market becomes too concentrated, the lack of competition might reduce the incentive for rapid innovation.
Is that
Direction
happening?
of innovation. A single company's strategic priorities and vision could disproportionately influence the direction of technological development, potentially sidelining alternative approaches or technologies that could offer different benefits or innovations. Competition and the free market barriers to entry. High barriers to entry in the market for AI hardware, including the substantial costs associated with research, development, and fabrication facilities, can limit the number of competitors able to challenge a dominant player. This can restrict market dynamics typical in a healthy competitive environment. Competitive landscape. While NVIDIA is a leading provider of GPUs for AI and deep learning, there are other players in the market, such as AMD and Intel, and emerging companies focusing on AI-specific hardware.
Okay.
Competition can spur innovation, but a highly dominant position by one company might stifle competitors' ability to challenge the status quo effectively.
Why?
Advancement of technology diversity of solutions. A monopolistic or near monopolistic market can limit the diversity of available technologies. In the context of AI and deep learning, this can mean that certain computational models or approaches are favored over others, not because they are necessarily superior, but because they are more compatible with the prevailing hardware.
Okay.
Dependency and risk. Over-reliance on a single company for critical technology infrastructure can pose risks, including vulnerabilities to supply chain disruptions, pricing control, and the potential for obsolescence if the company's technology is superseded. Looking at open standards and frameworks. The development and adoption of open standards and frameworks can mitigate some risks associated with market concentration. OpenCL, SYCL, and Vulkan are examples of efforts to provide cross-platform standards for parallel computing. Innovation beyond CUDA. While CUDA and NVIDIA GPUs are prominent in AI research and development, there is significant work being done on alternative architectures and software platforms. This includes efforts in quantum computing, neuromorphic computing, and other non-traditional computing paradigms. Government and regulatory intervention. In some cases, government or regulatory bodies might step in to ensure market competitiveness, either by enforcing antitrust laws, supporting open standards, or funding research in alternative technologies. In summary, while NVIDIA's dominance in the AI hardware space raises important questions about competition and innovation, the broader technological and economic ecosystem is dynamic. Efforts to promote openness, competition, and diversification in hardware and software development.
Well, tell me more about the innovation beyond CUDA. So, like, I realize that there exist other big companies, but there's a competitive landscape, right? You mentioned that there are AMD, there's Intel. So, like, why can't just an average Joe on the street with $5 in their pocket start doing this? Why is this so hard that like only a few, and sorry, I'm gonna say oligarch, but tell me if that word is appropriate in this context. Like, why can't more people make these? Like, there's so many tinkerers in the world that are just like fooling around with this. Like, right now I'm literally reading a book and doing examples on my computer. So like, why am I limited by having to buy specific hardware, and why can't I just continue my tinkering in a way that I overcome the fact that now I would have to buy GPUs from a specific company and I'm limited by what that company offers? Why can't I find a way to do it myself using whatever architecture for a GPU? Why can't I invent my own architecture? Like, I feel like back in the 90s or whenever, when the internet was coming to prominence, like, that was a key component of like why the internet became prominent, is like people could host things on their own servers in their own houses and like actually do significant things, like host a web page or like even work online and get paid to like help people manage their stuff. And they didn't have to be employees of one company in the world. They could just do it on their own. Why is AI so dependent on just these few companies? And is that a good analogy? Is that what the internet was like, where it was less dependent on just a few companies? Or was it kind of similar? Like there was just Microsoft and Apple back then, and when we look back at the evolution of the internet, it happened kind of in a similar way that AI is happening now. Can we make that kind of correlation, or are the two worlds just completely different?
You've touched on several deep and fascinating questions about technology, innovation, the competitive landscape, and historical parallels between the evolution of the internet and the current state of AI hardware development.
Yeah.
Let's unpack these themes. Barriers to entry in hardware innovation. Creating new GPU architectures or similar hardware requires immense resources, including research and development, R&D, costs.
Okay.
Designing cutting-edge processors involves significant investment in R&D, including paying for highly specialized engineers and researchers.
Yeah.
Fabrication facilities. Modern semiconductor fabrication plants, fabs, cost billions of dollars to construct due to the precision manufacturing processes required to create advanced chips. Economies of scale. Large companies like NVIDIA, AMD, and Intel benefit from economies of scale, making it difficult for smaller entities to compete on price and performance. This contrasts sharply with software development, where the barriers to entry are much lower. An individual with a computer can write code, create websites, develop apps, or contribute to open source projects with minimal upfront investment. The internet analogy. The early internet did benefit from a relatively open and decentralized model, where individuals and small groups could make significant contributions.
Exactly.
There was a diversity of players, from small startups to established giants like Microsoft and IBM, contributing to the ecosystem's growth. However, even in this space, there were barriers related to infrastructure, e.g., access to bandwidth and servers.
Yeah.
AI's development does have parallels in terms of reliance on big companies for significant advancements, similar to how early internet infrastructure and services were developed by a mix of large and small entities. However, the analogy diverges when it comes to the hardware aspect of AI, specifically the development of specialized processors like GPUs for deep learning, which is more capital intensive than software development or hosting web services. Innovation beyond big corporations. Despite these barriers, there are avenues for broader participation in AI and hardware innovation, open source and community projects. There are efforts to democratize AI through open source software, datasets, and pre-trained models.
Sorry, this is kind of interesting, but I might come back to this. I wish I could have it start reading like in a specific spot and not the whole thing. But I do want to. I just have so many questions. So many questions. I do need a quick break. I'll be right back. All right, I'm back. And I have a million questions. First, I need some hand sanitizer. All right, so the first question I have is like, I've heard of the Chips in Science Act, and like, what is that? Because I've just heard of this act as like being an important thing. Yeah, so it's called the Chips and Science Act, and it was published like 2 years ago, and I think it has to do with this. It has to do with the fact that there's like one company producing these things, but I don't know. So we've got a number of official sources. .gov, that should be fairly official. We've got Wikipedia. We've got the National Science Foundation. That's probably the best source. We've got Congress.gov. Will probably give us the full text pretty easily. So I'm actually, and I put on too much hand sanitizer. Oh, now it smells like alcohol in here. I'm about to gag. All right. Anyways, so here's a fact sheet from the White House. I don't care about the fact sheet. I want to see the facts. So here's the Congress.gov. It should have the name of the bill on it. So it's the CHIPS Act. Yeah, so I don't know why they're calling it the Chips and Science Act. Maybe that's just like a colloquial name, but it looks like the name of the law is HR 4346. Well, I wish it were more simple to see what the name of the law actually was. So we can see what happened. You know, it was introduced, passed the House, passed the Senate. There were some differences, which would be fascinating to see. President didn't veto it, so it became the law. So this is the law of the land in the United States right now. It's important. Hey, listen up here. This is important. You're gonna go straight to jail if you violate the Chips and Science Act. They got my neighbor last week. He was in the kitchen cooking up some CUDA NVIDIA GPUs. All right, so here's the so it says that NASA, like there's a lot of stuff about NASA, which is the National Air and Space Association. I don't know if anyone's ever heard of it. It's kind of a small company. They've done like a few kind of neat things. They've landed on the moon. That was kind of cool, but a lot of people kind of question if that was real or not. So it's just a small company. Anyway, so yeah, it's NASA, National Aeronautics and Space Administration. So there's a lot here regarding NASA. It's mentioned 55 times. It looks like we can listen to the act, which might be nice.
Secretary 10,646.
Let's do
this
that.
This section includes coastal acidification.
Let's listen to the act. So we're gonna listen to the actual act. We're not gonna listen to the news report. We're not gonna listen to the summary of the act. We're not gonna listen to anything. We're going to take a moment here and listen to the actual law of the land here. Which it's long. It's very, very, very long. And it's just a summary of sections, right? No, these are not links, thankfully. I thought it was just like a title of a section, and then you had to click the link and go to the section. But I mean, it's just like a sentence per line, so it shouldn't be that crazy, actually. Because it's like not very dense. It's double spaced. All right, let's listen to it.
There are 8 summaries for H.R. 4346.
Oh, these are summaries?
Bill summaries are authored by CRS. Shown here, Public Law No. 117 to 167-08092-022. This act provides funds to support the domestic production of semiconductors and authorizes various programs and activities of the federal science agencies. Division A CHIPS ACTOF 2022. CHIPS Act of 2022. Secretary 102. The Act establishes and provides funding for the Creating Helpful Incentives to Produce Semiconductors, CHIPS, for America Fund to carry out activities relating to the creation of incentives to produce semiconductors in the United States. The Act establishes and provides funding for the Creating Helpful Incentives to Produce Semiconductors, CHIPS, for America Defense Fund to carry out the National Network for Microelectronics Research and Development.
Military applications.
The Act establishes and provides funding for the Creating Helpful Incentives to Produce Semiconductors, CHIPS, for America International Technology Security and Innovation Fund to 1. Provide for international information and communications technology security and semiconductor supply chain activities, including to support the development and adoption of secure and trusted telecommunications technologies, secure semiconductors, secure semiconductor supply chains, and other emerging technologies. And 2. Carry out the Multilateral Semiconductor Security Fund and the Multilateral Telecommunications Security Fund.
I need this faster.
The Act establishes and provides funding for the Creating Helpful Incentives to Produce Semiconductors, CHIPS, for America Workforce and Education Fund for the National Science Foundation, NSF, for microelectronics workforce development activities to accelerate the domestic development and production of microelectronics, and strengthen the domestic microelectronics workforce. Secretary 103. This section expands the financial assistance program relating to semiconductor incentives to include production of semiconductors and equipment and material related to production of semiconductors. The Department of Commerce shall establish within the Financial Assistance Program an additional program that provides federal financial assistance to covered entities to incentivize investment in facilities and equipment in the United States for the fabrication, assembly, testing, or packaging of semiconductors at mature technology nodes.
Financial assistance program.
In awarding federal financial assistance to covered entities under such additional program, Commerce must give priority to covered entities that support the resiliency of semiconductor supply chains for critical manufacturing industries in the United States.
Hey,
No funds made available under the program may be used to construct, modify, or improve a facility outside of the United States.
Hey, that's good enough for me.
This section makes it an objective of the National Semiconductor Technology Center to grow the domestic semiconductor workforce.
Gimme.
This section provides for the capitalization by the Center of the Investment Fund to support startups and collaborations between startups, academia, established companies, and new ventures.
I'm a new venture in a startup.
This section revises the functions of the center to specify that its support to incentivize and expand participation in programs related to microelectronics shall be geographically diverse and include community colleges.
Yeah, I'm a graduate of one.
The National Institute of Standards and Technology, NIST, may establish not more than 2 more manufacturing USA institutes. Commerce may award financial assistance to any such institute for work related to semiconductor manufacturing.
Wait, why not more
Secretary
than 2?
104. The Department of Commerce shall establish activities within the financial assistance program relating to inclusion of economically disadvantaged individuals, minority-owned businesses, veteran-owned businesses, and women-owned businesses. Secretary 105. The Government Accountability Office, GAO, shall evaluate how the federal government could take specific actions to address shortages in the semiconductor supply chain, including 1.
I'm not trying to get canceled here, but I guess I'm out of the business because I don't. So let's see here. Shall establish activities related to inclusion of... I mean, maybe I'm economically disadvantaged. Specific activities within it. Okay, well you can just get a small scholarship. So I'm good. I'm doing this. I'm the next microchip zillionaire.
Demand-side incentives, including incentives related to the information and communications technology supply chain. And 2. Additional incentives, at national and global scales, to accelerate utilization of leading-edge semiconductor nodes to address shortages in mature semiconductor nodes.
Yes, ma'am.
Under such review, the GAO shall describe how projects are supporting the semiconductor needs of critical infrastructure industries in the United States, including those industries designated by the Cybersecurity and Infrastructure Security Agency as essential industries.
I'm bored.
Also under such review, drawing on data made available by the Department of Labor or other sources, an analysis of semiconductor industry data regarding businesses that are majority-owned and controlled by minority individuals or women. Or the number and amount of contracts and subcontracts awarded by each covered entity using funds made available under the Financial Assistance Program disaggregated by recipients of each such contract or subcontracts that are majority-owned and controlled by minority individuals or women. And aggregated workforce data, including data by race or ethnicity, sex, and job categories.
All right, that's fine.
This section includes in the annual report to Congress on the Public Wireless Supply Chain Innovation Fund, in describing how and to whom amounts in such fund have been deployed, to include whether recipients are majority-owned and controlled by minority individuals and majority-owned and controlled by women. Secretary 106. This section provides funding for the Public Wireless Supply Chain Innovation Fund. Secretary 107. This section establishes an advanced manufacturing investment tax credit in an amount equal to 25% of the qualified investment for a taxable year for any advanced manufacturing facility of an eligible taxpayer. The section provides for the application of such credit to partnerships or S corporations. Division B Research and Innovation. Research and Development, Competition, and Innovation Act. Title I Department of Energy Science for the Future. Secretary 10101. The Office of Science of the Department of...
I'm sorry, I can't do anymore. So I guess yes, there's a new law. If you are a minority-owned business, you can get a 25% tax credit in the something. Okay. All right, back. God, oh, sorry. Was there anything else? Well, let's read the summary of it because that I think that's. Let's see here. So here we go. Here's the fact sheet from the White House. Hopefully there's like a summary. Dumb it down. Dumb it down, please. I need that. So here's the fact sheet. So here's the facts. The first one, um, okay, so the first fact is that companies have announced nearly 50 billion in additional investments in American semiconductor factoring, which, I mean, this is one thing that was discussed during the pandemic. Is there's just a lot of manufacturing that's occurring in single point of failure ways. So if that factory goes down, the entire global production of semiconductors go down. So they want to try to fix that. So if one factory goes down, the other factory continues the production. All right, so total business investment is nearly 1.5 billion since 2020 or 2021, and so that's the total investment in American made semiconductors. And typically they're made in Taiwan, as far as I know. I don't know that much about this. So the next fact is, there's funding for the act. Yeah, I don't know. I just feel like this is all like super relevant to what we're reading about here, especially in regards to the CUDA GPU, because CUDA is a GPU architecture, and it's perhaps not the only architecture, but I think the Wikipedia article is probably going to be the best. So let's just read this and then move on. The Chips and Science Act is a U.S. federal statute. The act authorizes a lot of money to boost domestic research and manufacturing of semiconductors in the USA. It gives tax credits, subsidies. The act does not have an official short title. Okay, so Division A, yep, we saw that. Creating helpful incentives to produce semi-manufacturers. Division B, I don't think we got that far. Okay, there's Division B. Division B, Research and Innovation. Anyways, it's probably a good time to start a semiconductor business if you're in the United States, but when I say it's a good time, I say it's a better time than usual, and it's probably never that good of a time to do that. It seems like it's a bit hard. I would not know how to go about it. And I tried reading the act, and I did not get very far into it. So let's just continue focusing on the book and kind of leave that to the another video. Stay tuned for the next video when I start my own American semiconductor factory and dominate the global market. That'll happen in the lunchtime video, and I'll finish it up in the evening video. All right, so there we go. Deep learning with PyTorch. Now that the ecosystem for machine learning with Python has been defined, let's take a look at porting the simple linear regression example to PyTorch and run it on a CUDA GPU. So that's a type of GPU with the CUDA architecture. One easy way to get access to an NVIDIA GPU is to use Collab notebooks. And I've done this before. This is kind of like cloud services, but for accessing expensive AI GPUs. Collab notebooks are Google-hosted, Jupyter-compatible notebooks that give the user free access to both GPUs and tensor processing units, TPUs. You can run this code in a GPU. Now I have a decent GPU for like a gaming GPU, so maybe I could just use mine. It is an NVIDIA GPU. I can in fact look at my hardware. Yeah, device manager, and I can show what kind of GPU I have. So it's a display driver. It's a NVIDIA GeForce RTX 2060. I don't even know if that's good anymore, but when I got it, it was decent, and it's certainly enough to run games, just about any game I want, because that's how I spend my time, obviously. Okay, so next part is regression with PyTorch. First, convert data to float 32. So I'm not sure. I think this is going to be in the same. You know what? Let's not use collab notebooks. Let's just try it with my GPU. Let's try to break my expensive GPU, because that sounds like something I would like to do. So yeah, so I've got my Jupyter notebook running, so I need to go to it. So the cool thing about this is you can go to the ports tab and see everything you've got open. Now you can just click the symbol. There we go. And now we're back into the to where we were. So this is the one that was edited more recently. I don't know why it's still called untitled. Maybe I forgot to save it. Yeah, so let me rename it. We're gonna rename it Chapter 14. And now I'm gonna hit save. Maybe that's why. Nope, it's still. Okay, so there's some kind of issue where it won't retitle it. I'm not sure what's going on there, but it's fine. Everything's fine. It doesn't have to be perfect. It's not like I'm starting a semiconductor factory. All right, so next part is to convert data to float 32. So we do that with here. Oops, and I don't have to right click. There we go. Get out the book information, clean it up, which requires some knowledge of Python, but I have that knowledge. All right, so now I think I will run this cell. I'll actually, yeah, I'll run this cell. Okay, there we go. And now the next part, oops, and I accidentally skipped up a bunch. So now the next part. Alright, and I'll run this cell too. There we go, ran successfully. Note that if you are not using Collab notebooks, I will not be. You may have to install PyTorch, that is fine. Also, if you use Collab notebooks, you can have an NVIDIA GPU and run this code. If you are not using Collab, you will need to run on a platform that has a GPU. Okay, so if you don't have an NVIDIA GPU, you can use you can get one through Collab notebooks, but if you do have one, you don't have to worry about it, and you can just do it on your GPU. I have all the nice fancy things. If you don't, take a look at this Collab notebook. But I will not be going in. You can also look at like an older series I did that has it, but just if you have the internet, you'll have to research it on your own. So next part is to import Torch, which probably is not going to work. Oops, and I just need to do this and then do that. There we go. Get rid of the information here. All right, and then control enter. There we go. Module not found. So I do need to install it. So I'm going to figure that out. Don't know if that'll be easy or not. Think it won't. Okay, so I'm gonna shut down the server. Do a ls. Cat out untitled. Cat out the chapter 14. I don't know. I'm so confused. So what? The first thing that's confusing me is why it's not renaming my notebook. So I've got this one. Now I've got my server down, so I can't look at it. But I guess it doesn't matter. It doesn't matter for now, and I don't want to ruin things. So the next part is I need to install that module. So I've got my virtual environment open, so it should be as simple as pip install torch, right? Pip install, do an upgrade first, and then pip install torch. Looks good to me. I see a bunch of stuff about NVIDIA. Now this is a little bit dangerous. You do want to verify that that word torch is what you're looking for, because we saw before there can be kind of like phishing attacks where you install something that you didn't mean to install because somebody put up some sort of, you know, thing that tricks people to think they're getting something that they're not. But I feel like that's kind of a lot of effort, and then there's so many technically advanced people using this that it would get kind of caught pretty easily. But if you're using this for like a professional, you know, government or corporation, they'll probably already have internal safe software center things set up, but don't be the person that has malware on their work computer. I mean, I'm expecting it to take forever. It's a big package. Now let's look back at the quadrant and see where torch fits into that. And I'll have my bookmark be here. So torch fits in, I think it's PyTorch, so we're dealing with this with a deep learning framework. And I can remove this older bookmark. Now my computer is slow. That's fine. That makes sense because installing this deep learning application should tax my computer a bit. I think I can probably do a Control-Alt-Delete on it, which kind of taxes it on its own. And then look at the task manager. And then go to performance and see what is happening. Okay, so we can see the memory's at 80%. Disk is at 100%. Now this is probably the big one. This is monitoring my GPU directly. So video encode is maxed out, or is at 70%. So yeah, my utilization's at 71%. This is probably important to have up. 52 degrees. That seems pretty hot. I'm a Fahrenheit guy, so 52 Celsius to Fahrenheit. Okay, yeah, it's pretty hot. Human skin burns at 118. Don't touch the GPU. All right, I think this is going to take a while. This is a big deep learning package, so I'm going to pause it and be back. And I might even end the video on this. So let's see what we got here. Yeah, so this is just going to be a lot of stuff. It's creating an actual machine learning model. So I feel like it's not going to be a small thing, and it kind of warrants its own video. So I think I'll end the video after this is installed, and then go through this whole example in its own video. So I'll pause it and be back. Okay, I'm back. So everything was successful. We don't have any errors. That was really nice and easy. And GPU is back to higher utilization than it was. I don't know what the deal is with that. But the disk is way lower. Memory's about the same. So temperature's the same on the disk. So not much of a change there, but let's move on. And I said I kind of wanted to end the video. No way. I'm feeling good about this. I'm really excited about moving forward with this. So I will do that. So the next command will be Jupyter Notebook, like this, to start up the notebook server again. And now we can click open in browser. And I've got my notebook back. This is the one I'm using. I wanna delete this one. Yeah. Okay, and that's why I couldn't rename this, because I was renaming it to something that already existed. All right, so now I can rename it to chapter 14. There, and now we can see it actually renamed because there's not a file already existing named that. Okay, so now if I go back and try to run this again, Now it goes without issue because I have that installed. Okay, so the next part is defining this class. Get rid of the author information. And here's where you just kind of have to know something about Python in order to rearrange this, because there's white space rules and you have to know those rules. Okay, so here's the definition syntax, which ends in a colon. So then this is on another line. And again, I just know things. All right, looks good to me. So here's the class, linear regression. So we define what happens when you call the class. That's what this means. So when you call the class, so when you call the class, you have to pass in this object to it, the torch.nn.module object. That object should have input size and output size. So it will initiate. So when you call the class, what it will do is it will take the input size and the output size, and it will do this here. I don't know what this super is. Let me try to run it. Look, perfect. And instead of me giving the rundown on this, let's have ChatGPT give the rundown on this, because that's awesome. Okay, so give me a rundown on what each line of this code does. Each line of this code does. All right, and I have to get rid of that. Oops, and for some reason it looks like it didn't. So this can go away. This here. Let me just try a Control C on it. All right, and then a Control like that. Okay, there we go. And now I'll go like this. I'll do blah blah blah, and I'll do give me a rundown of what each line of the above code does.
The code snippet you've shared defines a simple linear regression model using PyTorch, a popular open source machine learning library. Let's break down what each line of the code does. This line defines a new class named linear regression that inherits from Torch, NN, module. Torch, NN, module is the base class for all neural network modules in PyTorch. By inheriting from this class, linear regression gains functionality that is useful for creating a neural network model, such as keeping track of parameters. This line defines the constructor of the linear regression class. The constructor is a special method that is called when a new instance of the class is created. It takes two arguments, input size and output size, which represent the number of input features and the number of output features respectively. This line calls the constructor of the parent class, Torch, NN, module, to ensure that the initialization logic in the parent class is executed. This is necessary for PyTorch to set up a model correctly. This line creates an instance of a Torch, NN, linear class and assigns it to self, linear. Torch, NN, linear is a module that applies a linear transformation to the incoming data, y equals x a caret 2 plus b. It requires the number of input features, input size, and the number of output features, output size, as parameters. This line essentially defines the linear model y equals wx plus y equals wx plus y equals wx plus b, where www is weight and bbb is the bias. This line defines the forward method, which overrides the forward method in the parent class, Torch, NN, module. The forward method defines how the model processes input data, x. In PyTorch, you define the forward computation of the model here, and the backward pass, where gradients are computed, is automatically defined for you using AutoGrad. Within the forward method, this line passes the input x through the linear transformation defined earlier, self, linear. The result of this operation is assigned to out, which is the predicted output of the model. This line returns the output out of the model when given an input x. This is what you'd use to get the model's predictions. Note, there's a small indentation issue in the provided code.
Oh, really?
The def forward self x method should be aligned with the def underscore underscore init underscore underscore self input size output size method, meaning it should be
Oh,
defined
really?
outside of the underscore underscore init underscore underscore method, but still within the class.
Is that true?
This ensures that the forward method is correctly recognized as part of the class's definition.
Now there's one space here. I don't think that's true because this is indented. The forward method. Oh, right. Well, let's see if that's true as we go on. So now we're going to create a model with CUDA enabled, assuming you are running in Colab or on a machine with an NVIDIA GPU. I'm running it on a machine with an NVIDIA GPU. So the first thing we got to do is paste in, oops. Oh, I highlighted it by accident. There you go. Now I need to copy this, paste it in with the author information, delete that as soon as possible, and then move on to the next page, progress my bookmark, and all this code goes in there. All right, so these are inline comments here. So the next line is here, and here, and here, and here. There we go. So, yeah, and I think the indentation was how it was meant to be. I don't know. We'll see, because it should have if it's linear regression dot forward, then we know this was incorrect. But I don't see that now. So we got the same thing. We got the in features 1, out features 1, bias is true. So let's create the stochastic gradient descent and loss function. It sounds like every young child's dream. I'm surprised there's not Disney movies created about that. Alright. So we got two lines here, the criterion line and the optimizer line. We're not using this linear regression class, so let's see if this runs. Okay, seemed to run fine to me. So next we're going to train the model. If I had to type all this out, it would be impossible. Okay, so there's a for loop here. Let's see if there's any more lines. Yep, a lot more lines. Okay, so there's an inline comment, get gradients WRT to parameters. And then the next line I think is here. A little bit of guesswork involved in this, but if it runs, it runs. Update parameters, optimizer.step. Then we're going to print this out. And we can see everything's still indented, so it belongs under the for loop. And that's it. That's the last line. So there's going to be output yeah, so there's going to be a lot of output here, but let's see if this works. So xtrain is not defined. Now it's defined here. So, and it's spelled the same here. So it is defined. I don't know. It might have something to do with my kernel. So I'm going to do that. I'm going to do kernel, restart, and clear all outputs. And then we're going to run each of the cells. I can do that because I'm not using like a cloud service. So it's just my own hardware. And now all the cells are running. We're working on, so we see the asterisk, so we're working on cell 8 here. Cell 8 went good. Skip through all the other ones really fast. Oh, and now we got the same, oh, we actually got a different error. But now we know that it's not because xtrain was not defined. We've got a different error here. So, so it's missing the forward function. So ChatGPT called it. I don't know what I would do without ChatGPT. It's wonderful. This needed to be like that. So now we can do that again. Clear all outputs. And then run all cells. Okay, so it takes a while to run this one. Generating a graph here. Yep, there we go. There we go, and ChatGPT called it. Now, look at how nice this output is. It comes here with a scroll bar down to see everything. Jupyter is really nice. I do recommend getting comfortable with Jupyter. It's really not hard once you understand that things that it serves as a browser in the terminal, and then you open it up in the browser. It just serves as a server. So it's just sitting here as a server. You don't do anything with it here. Now, if I were to save the file, you could see another line here shows that it was saved again at this time. So, like, it'll show you messages based on it, but once you understand that this just hangs like this, and it's hosting the application, and you know how to go to the ports tab and click the button for the right one. If we go to this one here, you know, this is for something else. So once you understand how to get to it and how to use it, and then the kernel, restarting the kernel, all that, I do definitely recommend switching to Jupyter Notebooks as soon as possible. So they've got output from over 1,000 runs. Not sure how many runs I've got. Looks like the runs aren't being counted. So we do have this epoch number here. It looks like that is the runs. So we've got our 0th run. Let's look at the 10th run, which would be epoch 9. And then let's see how many runs we got total. 999. So we got 1,000 runs. And that should be in the code somewhere. So yeah, epochs. So we should have defined epochs as 1,000. So we can do 10,000 here, 1,000,000. We can change this if we want more or less runs. All right, so we got more or less the same output there. Next step is to plot predicted height versus actual height. Now let's plot the predicted height versus actual height as in the simple model. So we should get more accurate results. Okay, so this is a with statement in Python. So everything under that gets indented and happens with this. So like with kind of classic use of with is with a file open, you can read from or write to the file. It's a pretty long line here. Huh. Model variable torch. CUDA. So there we go. That's closed up. And then I'm not sure what this is. I think this is to indicate that it's meant to go on another line, but I don't know why there's a... I guess I'm kind of confused by this syntax here. Now the print statement, that's a freebie. No, that goes on another line. So print predicted. Then this is on its own line. This is on its own line. This is on its own line. PLT legend. Now, okay, so some of this got cut off. I'll just type out the part that got cut off. There we go, and this looks good. I'm not sure what's going on here. I guess I'll run it, and if it doesn't work, I'll go right to ChatGPT. So we've got a unexpected character after line continuation character. So yeah, this is just a line continuation character. So that means that I could put this on the other line, and it would look as though it was like that. But it's fine. I'm okay with it being that long. We can see all the parentheses are closed. We got this is what's cool about Jupyter as well. We got some good syntax highlighting there, so should work now. And there we go. Now we get a fancier graph based on a machine learning model. This should be quite a bit more accurate, hopefully, or quite a bit less accurate, maybe. But yeah, so this is the RMSE, which we learned about. It's the root mean squared error. So like if you're playing a beanbag game, and your beanbags are closer or further from the target, you can tell how good you are at that game by calculating your RMSE, your root mean squared error, because that will say on average how far is your throw from the target. So better players will have an average throw that is closer to the target than worse players, even if a worse player happens to beat a better player at any particular game. So that's a pretty cool concept, because you can, if somebody beats you at something, you can say, well, you may have beaten me this time, but my RMSE is way better than yours, so let's play 100 rounds and see who wins. And you will win for sure, assuming you are the better player. All right, so finally, let's print out the RMSE and compare. The RMSE is awesome, because as I mentioned before, I'm a amateur juggler. You can check out some of that on my other channel. So knowing the RMSE of my throws and reducing the RMSE of my throws would be revolutionary. And machine learning can do that. I've actually worked on computer vision projects, and I have the data. I'm just not sure what to do with it. But one of the things I could do with it is calculate the root mean squared error of my throws. All right, so we should get an output similar to what they got. Oh, so my output is quite a bit different. It's almost, well, it's not quite double, but it's 105 where they got 59. Double would be more like 120, but it's like maybe 1.8. Okay, so it does take a little more code to do deep learning, but the concepts are the same from the sklearn model. The big takeaway here is that the GPUs are becoming an integral part of production pipelines.
The discrepancy between the root mean squared error, RMSE, you obtain, approximately 105, and the one reported in the book, approximately 59, can be due to several reasons. Data differences. If the data sets are not identical, the RMSE will naturally differ. This can be because of different splits between training and test sets, data preprocessing steps, or updates to the data set after the book's publication. Model parameters. The model training process might have used different hyperparameters, which can greatly affect the performance. For example, different learning rates, regularization terms, or numbers of epochs can lead to different RMSE values. Random seed. Machine learning algorithms often have a random component to them, such as the initialization of weights. If the random seed isn't set to the same value in both your code and the book's example, the results could vary. Feature engineering. There might be differences in the feature engineering steps applied to the data before training the model, such as normalization, scaling, or selection of different feature subsets. Software versions. Different versions of the libraries used, such as scikit-learn, NumPy, etc., can sometimes lead to different results due to changes or optimizations in the algorithms. Data leakage. If there was some form of data leakage in either your approach or the books, where information from the test set is inadvertently used during training, this could cause discrepancies in performance metrics. Error in code. There could be a bug or mistake in either your code or the book's code. This could be as simple as a typo in a variable name or as complex as an error in the logic of the data processing or model evaluation. To troubleshoot this discrepancy, you could double-check the code for any mistakes. Confirm that the dataset is the same and that you're using the same features. Verify that the model configuration and parameters are identical. Make sure you're using the same versions of any libraries and tools. Set the random seed to a fixed number to ensure reproducibility. Review preprocessing steps to make sure they match the book's methodology. Look at the variance in RMSE across different runs to see if the model's performance is consistent.
Oh, that's a good thing we could do is just keep running it again and see if let me do that actually. So I'm gonna run the whole playbook again. I'm gonna save this this number here. So and then we'll see if it's the same number on the second run through. Close that. Well, let me see here. Let me open Notepad++, which I don't even have it installed. Okay. Well, where can I put this number? I'll take a screenshot of the number. Okay, so let's run this again and see if we get the same number. Oh, now the number was totally different. Wow. Okay. So yeah, I probably wouldn't trust these results if it was some like real production thing. Let me run it one more time. So we got 105, then we got 17. Let's see what we get now. Any bets? Big money, big money. Okay, now we got a totally different number again. We got 119. So I want to run more time. Want to run it one more time because I'm curious if I'll get a low number now. Nope, I got about the same on 120. So it doesn't seem to be a pattern there. It's just kind of not consistent. Models. So the last word of this section is models. So even if you aren't doing deep learning yourself, it is helpful to have a basic awareness of the process of building GPU-based machine learning models. So I guess I have some understanding of that, but I don't understand the results. They don't seem to be accurate. Alright, so that's it for this video. I'll clean up my bookmarks here. There we go, and that's it. I got everything to work, but I can't be assured that my output is accurate. But I mean, that's better than just not having it work at all. So stay tuned for the next video.